Let us see what is the theorem of geometric mean. In a right angle triangle, the length of the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the lengths of the segments into which the hypotenuse is divided. What is given? In triangle PQR, this is the triangle PQR. Angle Q is 90 degrees. This is a 90 degrees angle. Then sec QS is perpendicular to sec PR. This QS is perpendicular to PR. PR means hypotenuse. And we have to prove that this segment QS is the geometric mean of PS and SR. That means QS square is equal to PS into SR. We have seen that if A, B, C are in geometric progression, then B is geometric mean of A and C. This is same as B square is equal to AC. So if here QS is the geometric mean of PS and SR, this will mean QS square is equal to PS into SR. Proof is very simple if you know similarity. So here triangle QSR and PSQ are similar. This is by similarity of right triangles. Here suppose in this figure the measure of this angle is suppose X. Now in triangle PQR, angle P we assume to be X. Angle Q is given to be 90, and therefore if you see angle sum property, measure angle P plus measure angle Q plus measure angle R, measure angle P plus Q plus R is equal to 180 degrees. So P if we assume to be X, Q is given as 90, and plus measure angle R is equal to 180. So measure angle R if we want, angle R will be equal to 180 minus 90 minus X. So 180 minus 90 is 90. So R will be 90 minus X. This R is 90 minus X. We know that the acute angles of a right angle triangle, they are complementary. So if this is X, this is 90 minus X. Their sum becomes 90 and the third is 90. So it is 180. Now in the triangle PQR, this is X. So this becomes 90 minus X. Now if you consider triangle QSR, this is QSR. In QSR, the measure angle Q is X. QSR, this is X, because if this is 90 minus X, this is 90, so this will become X. So in triangle QSR, Q is X. In PSR, if you consider PSQ, P is X. So angle Q is equal to angle P. Now in triangle QSR, S is 90. This is 90. And in PSQ, if you consider PSQ, S is 90. And therefore, in triangle QSR and triangle PSQ, angle Q is equal to angle P, each is equal to X. Q is also X, and P, if you consider, here Q is this X, and here P is X. And here S is 90, S is 90. This one is 90, and this is 90. Triangle QSR is similar to triangle PSQ. And therefore, their corresponding sides will be in same ratio. So QS upon PS, this is QS upon PS, will be SR upon SQ. These are the corresponding sides of similar triangle. So QS upon PS is equal to SR upon QS. So QS square, if you take cross multiplication, this becomes QS square, and this is PS into SR. This is called as theorem of geometric mean. We are going to study when we shall study the chapter in detail, but today we can study this as a small property. How it is used, see here. In a right angle triangle, the length of the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the lengths of the segments into which the hypotenuse is divided. This is the theorem of geometric mean. Now here given in triangle PQR, angle Q is 90. QN is perpendicular to PR. This QN, this segment, is perpendicular to PR. That is, it is perpendicular to hypotenuse. Now PN is given as 9. PN is given as 9. And NR is given as 16. This NR is given as 16. And you are asked to find QN. This QN. So solution, in triangle PQR, Q is 90 and say QN is perpendicular to PR. QN is perpendicular to PR, this is given. And the theorem of geometric mean states that in a right angle triangle, the length of the perpendicular segment to the hypotenuse, that is length of this segment QN, is the geometric mean of lengths of the segments into which it is divided. So QN is the geometric mean of Rn and Np. That means Qn square is equal to the product of this, Pn and Nr. This is Pn and Nr by geometric mean property. Now Pn is given as 9. So this is 9 and Nr is given as 16. Now if you take square roots of both sides, the square root of Qn square is Qn, square root of 9 is 3 and square root of 16 is 4. You need not multiply this. Even if you multiply, you are getting the same answer. 16 nines are 144. You may get that 144. And if you take square root, that will also come out to be 12. But whenever these complete squares are there, you need not take square root. So square root of, you need not multiply them. Directly you can take square roots. Square root of 9 is 3. Square root of 16 is 4. 3 into 4 is 12. So Qn is 12 units. Second sum. In a right angle triangle, this is the theorem of geometric mean I am again explaining you. In a right angle triangle, the length of the perpendicular segment to the hypotenuse. In this triangle PQR, angle Q is a right angle and PR is the hypotenuse. This is the perpendicular from the opposite vertex to the hypotenuse, that is QS. This is the geometric mean of PS and SR. So QS square is equal to PS into SR. This is to be used. So here question is in triangle PQR, angle PQR is 90. This angle is 90. Say QS is perpendicular to PR. Find X, Y and Z. So X is this, Y is this and Z is this. These are asked. Now here by geometric mean property, QS square is equal to PS into SR. QS square is equal to PS into SR. So PS is given as 10, SR is 8. So QS square is equal to 10 into 8 is 80. Taking square roots, square root of QS square is QS. This is square root of 80. This you can factorize. 16 into 5 is 80. The square root of 16 is 4 and square root of 5 we are writing for root 5 only. Therefore the value of X is 4 root 5. This X is 4 root 5. Now, in QSR, here, in QSR, major angle QSR is 90. This is 90. And therefore, by Pythagoras theorem, QR square that is square of the hypotenuse, is equal to sum of the squares of the other two sides, qs square plus sr square. Qs square plus sr square. Now qs we found out to be 4 root 5. So qs square means 4 root 5 square, and sr square means 8 square. So 4 square is 16, root 5 square is 5, plus 8 square is 64. 16 into 5 is 80 plus 64. That comes out to be 144. That is the square of 12. So QR square is 12 square, and therefore taking square root, QR is equal to 12. That means y is equal to 12. QR means y. So this y comes out to be equal to 12. This we did by using Pythagoras theorem. Now we have to find z also. In triangle PSQ, measure angle PSQ is 90. PSQ, this is 90. And therefore by Pythagoras theorem, PQ square on the hypotenuse means PQ square, Z square is equal to QS square plus PS square. So PQ square is equal to QS square plus PS square. Now QS we have found out to be 4 root 5. This is 4 root 5 square plus PS square. So PS is given as 10. This is 10 square. 4 root 5 square means 4 square is 16, root 5 square is 5, and 10 square is 100. 16 into 5 is 80, and 100 is 100. 80 plus 100 is 180. And therefore, we want to find PQ. So we are writing this in the square form. If you find 180 is equal to 36 into 5. 5 6 are 30. 0, carry over 3, 5 3s are 15 and 3 18. So this is 36 into 5. So if you take square root here, PQ is equal to square root of 36 is 6. Square root of 36 is 6, and square root of 5 is root 5. This is 6 root 5 square, so PQ is equal to 6 root 5. And PQ means Z. Z is equal to, this Z is 6 root 5. Now here also you'll find that in the figure, measure angle MNP is 90. MNP is 90. Sec NQ is perpendicular to sec MP. This is perpendicular. MQ is given as 9. And QP is given as 4. You are asked to find NQ. So here also you will find that the geometric mean property applies. The perpendicular on the hypotenuse from the opposite vertex. This you can say altitude on the hypotenuse is the geometric mean of the segments into which the hypotenuse is divided. So solution, in triangle MNP, angle MNP is 90 given, and sec NQ is perpendicular to MP given, and therefore by geometric mean property, NQ square, this NQ square is equal to MQ into QP. MQ is given as 9, QP is given as 4. So NQ will be equal to, taking square root of 9 is 3, square root of 4 is 2, 3 into 2 is 6. So NQ is equal to 6 units. Here in the figure, triangle QPR, measure angle QPR is 90. This angle is 90. Sec QR is perpendicular to PM. This PM and QR, they are perpendicular to each other. This is 90. And Q dash M dash R. M is between Q and R. PM is given as 10. This is given as 10. Then QM is given as 8. QM is given as 8. You have to find QR. This is to be found out. Solution. In triangle PQR, measure angle QPR is 90. Measure angle QPR is 90. We are going to use geometric mean property. So for geometric mean property, we require a right angle triangle. So first we start with, in triangle QPR, angle QPR is 90. Sec QR and sec PM are perpendicular to each other, given. And therefore by geometric mean property, PM square is equal to QM into MR. This is PM is given as 10. So PM square is 10 square, QM is 8 and MR is to be found out. Therefore MR is equal to 10 square upon 8, that is 100 upon 8, that is 12.5 units. MR is equal to 12.5. You are asked QR. So QR is equal to QM plus MR, because Q dash M dash R, M is between Q and R. QM is given as 8 and MR is found out to be 12.5. So 8 plus 12.5 is 20.5 units. In triangle DEF, measure angle DEF is 90. Sec FG is perpendicular to DE. DG is 8. This DG is given as 8. FG is 12. This FG is 12. You have to find EG. So EG you can find by using geometric mean property. Geometric mean property says that 12 square is equal to EG into GD. 12 squares means 144 is equal to EG into 8. So EG will be 12 square upon 8. If you are asked to find FD, so to find FD, you can use Pythagoras theorem, because this is right angle given. So FGD, in triangle FGD, this is right angle. This side is given as 8, this is 12. Using Pythagoras theorem, you can find this. And to find EF, if you want to find EF, you can use again Pythagoras theorem, because this side is given as 12. This we have already calculated. So using Pythagoras theorem, you can do this.